Thank you so much for the invitation and for the opportunity to present this new work. As you mentioned, here we're going to simulate the survey of professional forecasters with large language models. Some of my great co-authors are here on this paper. As you said, we are from different institutions. Ali is a graduate student, is an excellent graduate student in our program. And the usual disclaimer applies, given that Anne is at the Federal Reserve Bank of Richmond. So the paper does not necessarily reflect the views of the Federal Reserve Bank of Richmond or the Federal Reserve System. So let me start by discussing what motivated us to do that, right? To simulate the survey of professional forecasters using large language model. So in terms of broad motivation, economists and policymakers have increasingly relied on surveys as a measurement tool for capturing important variables, such as, for example, unobservable variables like inflation expectations or other expectations about future economic indicators and conditions. So surveys offer many benefits. As I mentioned, for example, we can capture variables that are difficult otherwise to observe in the field, but in some cases, they also face some limitations. Examples of limitations include that they could be expensive. In some cases, they can be done only at relatively low frequency. Sample sizes might be small. And there could be lack of flexibility. For example, it might be difficult to change instrument from one wave to another if you want to add some specific questions. So the question that we ask here is, can we leverage large language models to address these limitations? And we are specifically interested in the context of professional forecasting, where for example, the survey of professional forecasters suffers from some of these limitations that I just mentioned. The question is, why large language models and what are exactly large language models? So just broadly speaking, I'm not sure how many people are familiar with large language models, but these are AI models designed to process and generate human language by leveraging advanced machine learning techniques. They're called large because they rely on many parameters and a massive amount of data. They work by predicting the next token in a sequence, for example, the next piece of data, if you like, in a sequence, for example, the next word in a sequence. If I'm saying peanut butter and, there is a high chance that they are going to predict jelly, right? And they do that by leveraging massive text data sets to learn language patterns. So they are trained on massive data sets. So by now, they can do a lot of stuff, right? Probably many of you are using it already. And they can be used for many different types of tasks, for example, for writing more generally, summaries, for example, to write code to solve programming problems, answering questions, translating between languages, and also relevant for our purposes, analyzing complex data and capture trends and data patterns. So why do we use large language models? Well, these capabilities make them a valuable tool for automating tasks, enhancing productivity, and extracting insights from data. And here, indeed, we explore their potential as a forecasting tool. So note that actually ex ante is not clear whether large language models would do well in forecasting or not, because on the one hand, they have the advantage that they can efficiently process data, right? And large data sets and capture trends and patterns. On the other hand, humans, though, rely on quantitative models, more specialized models, and their own judgment. So ex ante is not necessarily clear, right, how they would compare to human forecasters. So what do we do in this paper? We actually simulate the survey of professional forecasters using large language models. We chose the survey of professional forecasters because it is widely used both in research and for policy making. and also suffers from some, when I'm going to give you a background for the survey of professional forecasters, also suffers from some of these limitations I mentioned initially. We actually create personas based on hand-collected characteristics of the survey of professional forecaster panelists. And we generate basically AI forecasters designed to mimic professional forecasters. We provide the model with these personas and data. I'm going to tell you what kind of data we provide the model with. And we feed these forecasters parts of the instrument, of the survey instrument, of the survey of professional forecasters. So we basically ask forecasters to provide point forecasts for more than 20 variables, and also at different horizon lengths, at different quarters of the years. And we also do a lot of robustness exercises to address potential concerns about reproducibility and robustness more general. So I'm going to discuss some of those, but basically we simulate also the survey, right, without persona, without real-time data, without past median forecast, and so on and so forth. So what are the main findings and interpretation, if you like? So the main findings are that indeed AI forecasters perform well across many variables and time horizons, and they often outperform human forecasters. Not surprisingly, perhaps, they tend to exhibit lower disagreement than human forecasters. So the forecast of AI forecasters tend to be less spread, right, than the ones of humans. And also, providing data in persona enhances their performance. So what is the interpretation? We discuss, hopefully towards the end of the talk, also we're going to have more discussion on the interpretation. But broad message that we think our paper provides us that large language models have the potential to be a higher frequency, lower cost approach, complementing traditional survey methods. And they can be a reliable new tool for economic research and policy making with human oversight. So again, we're going to discuss more towards the end. Our model is relatively simple, off the shelf. Still, it manages to capture to do better in many cases than humans. So we believe there is a lot of potential because the model could also be improved along several dimensions, right, with, again, human oversight. So we'll discuss more the interpretation towards the end. So in terms of related literature, I'm not going to go too much into detail, but I just wanted to give you a broad view of how our paper fits into the literature. So there are many papers, actually, in many papers that use the survey of professional forecaster data to do different comparisons or not to explore different questions. One that is that I'm going to cite also at some point here is Stark 2013, because it documents, basically launches a survey on professional forecasters to better understand what kind of models, how basically they come up with their forecast. And it documents that they use different type of models, quantitative models, but also their own judgment and current data or recent trends. So our contribution here, also important, actually, Jonathan has a paper showing that personal characteristics influence macroeconomic predictions. So that's important also in terms of generating personas, right, as a motivation to generate personas. But our contribution here, and here I put some, I left this bullet point empty because, there are many other papers, right? So here are just some examples. But our contribution here is just, none of these papers use a large language model as a forecasting model. So here we develop a novel framework that combine actually large language models with the survey of professional forecasters structure and data. A very closely related stream of the literature, and which keeps also growing. So if I'm missing actually anything important and closely related here, please let us know, because the literature is literally exploding every day. So, but a closely related stream is the one providing forecasting models with large language models. So the first paper shows, basically also simulates the survey of professional forecasters, but in particular, they focus on the inflation forecast and use a different model. And this is Alan et al. This is actually just a website where they use large language models to develop real-time macroeconomic forecast for some variables. So our contribution relative to this is to incorporate forecast heterogeneity, right? We create those persona. We actually compare different models. I'm going to have more to say about which models later. And we also importantly use we simulate the survey for more than 20 variables and for a long time period. So this allows us basically to complement the literature by providing a more comprehensive assessment of the performance of large language models in forecasting. And then there is also literature which is also growing at a fast pace, comparing AIs with human performance and in different contexts, game theory or in terms of simulating behavior. And for example, Zari Fornarvar, one of our co-authors, uses large language models to simulate the New York survey of consumer expectations. And our contribution relative to this literature is that we apply large language models to professional macroeconomic forecasting. So let me give you a little bit of a background on the survey of professional forecasters, and then I'm going to tell you how we simulated and the main results, and I'll discuss some robustness exercises. So what is the survey of professional forecasters? This is the oldest quarterly survey on macroeconomic expectations in the US. It was launched in 1968 by the American Statistical Association and the NBR, but was conducted by the Federal Reserve Bank of Philadelphia since 1990. This is widely used, as I mentioned, by policymakers and researchers. And the SPF data segment that we're going to use in our paper to compare, right, the human data with AI data, for our purposes, we're going to be focusing on the intervals between 1999 and 2023. We didn't use years prior to 1999 because for those years we didn't have basically the names and affiliations of forecasters were not publicly available. And we are going to use the point forecast for more than 20 variables at different horizon lengths. For example, current quarters or nowcast, 1 quarter ahead, 2 quarters ahead, up to 4 quarters ahead. And the survey is divided in 3 sections. The first section is on US business indicators. The second section is on real GDP and its components. And the third one is consumer price index and personal consumer expenditure inflation. Let me give you an idea of how it looks like. Okay, so that's here it's just focusing on 2 sections with the point forecast. They also have a section on density forecast where they elicit probability distributions, basically probability of different percentages of inflation happening over certain years, right? But here we're going to be focused on point forecast. So that's the first section. So you can see there are the number of variables. They are given the realized variables for Q1, and then they have to put their forecast for Q2, Q3. This is Q2, so this would be the nowcast. And then they do 1 quarter ahead, 2 quarters ahead, the 3 and quarters ahead. And they are given, I mean, there is a full definition of variables. So again, for our purposes, we're going to be focusing on point forecast and this time interval. There are roughly, actually, before I move on, let me just mention, I was mentioning some of the limitations. So this is a quarterly survey data. So again, in terms of frequency, ideally, if we had higher frequency, would be desirable, right? So in terms of sample size, also this is a specialized sample size, right? There are 40 rotating panelists, and these are experts from forecasting firms, banks, or other financial institutions, and academia as well. There is typically a call for participants on their website where you can apply. I think they check the initial surveys, and then you can, you can become a panelist. And some stay for longer time of period, some shorter. That's why, here I mentioned rotating. So it's not always the same group of people over time. They rely, as the paper by Stark documents, panelists typically rely on quantitative models, and this could be actually different type of models. So could be, for example, time series, ARIMA models, or it could be some other forecasting models. But they also use their judgment to interpret model forecasts and to interpret the data, and also adjust for current conditions and recent trends. Individual forecasts are kept confidentially, right? So they are anonymous. They have some IDs, so we can link some in our data. We can link some ID to the forecast, but we don't know who is behind that ID. However, the published surveys include the names and affiliations of recent contributors, okay, after 1999. And this is an example of acknowledgements. This is important because that's what we're going to use. We're going to use this information to create personas. But as you can see, they acknowledge, you can see the name of the forecaster and their affiliation. And you can see here also that there are different type of institutions like banks, JP Morgan or Wells Fargo, but there are also academics, East Carolina University, and so on and so forth. And actually, for more information about this survey, there is a great website by the Philadelphia Fed that provides a lot of information. So how did we simulate this survey with large language model? What did we do? So we generated AI forecasters with personas. So how did we create this persona? Where we used these publicly available data, basically the names and the names of the forecasters and their affiliation with hand-collected data. So we were basically looking for additional information that would be available online, either through LinkedIn, their personal website, and so on and so forth. And using that, we found information, for example, about their education, job title, affiliation, degree, professional role, social media participation. Here is a list of characteristics. So the full name, right? We got it from the forecaster as listed in the acknowledgement panel, an example that I just showed you. Then we had the affiliation, the highest degrees earned, their field, graduation here that we used to estimate experience and age, and so on and so forth. And indeed, there is some heterogeneity in characteristics and sectors, just to give you an idea. So in terms of degree, most of them are either PhD or master. So these are overall also sophisticated, right? Professional. I mean, they're called professional forecasters for a reason. And they come also from economics and finance, but also business management and other fields. In terms of sectors, they come from consulting, universities, or investment banking, commercial banking, asset management, and so on and so forth. And also in terms of positions, there is some heterogeneity. So then what did we do? We used as a large language model, we basically fed the large language model with these personas, and I'm going to tell you what kind of data. Which model did we use? Here we used GPT. The results I'm going to show you today are going to be focusing mainly on the results from GPT-4o Mini and the prompt with personas and data. We did some robustness analysis with other models. And the results are robust. GPT 3.5, which is an older generation, tends to perform worse. DeepSeek has a performance similar, very similar to 4o Mini. So then what do we do? I mean, the second bullet point, the fact that we use OpenAI assistants, just a tool that basically allow us to customize our queries and get intelligent answers because we want to answer in a specific format. This is basically just, I put this bullet point just to indicate that is in our work, we just don't open ChatGPT and put our prompt and then everything works well. There was a bit more work behind the scenes, right, in order to get intelligent answers. We provide personas. In terms of data, what kind of data we provide? We provide actually the past quarter median SPF forecast, real-time macroeconomic data, so the latest data, and we basically ask for point forecast similar to the SPF instrument that I just showed you. Okay, the example that I showed you. So here is the prompt, right? We use. We mentioned you are a participant. So the first 5 lines here are about creating the persona, if you like, right? So we mentioned that they are a participant on a panel of survey of professional forecasters, what their name is, where they graduated from, education, and so on and so forth. So these lines, the first part, right, of the prompt is about the persona. Then we tell them in which quarter they are, right? For example, 1999 quarter 4 or 2011 quarter 2, and so on and so forth. That they are about to fill out the forecast form for this date. We importantly restrict, right? Restrict them not to look at future data, right? Because I mean, future data, if we ask them for the second quarter of 2011, that data is now available, right? So we, to control for as much as possible for data leakage, we just say, using only the information available to you as of date Q, provide your best numeric forecast for the following variable. In the robustness exercise, I'm going to show you what happens if they can recall, okay, if we give them ability to recall. Do this there is a question.
Yeah. What about revisions to data?
What do you mean revisions?
The data available today for the second quarter of 2011 is not necessarily the data that was in the hands of real forecasters in 2011. Like for GDP, there are revisions for other macro.
Yes. Okay. So here we just tell them to only keep in mind. I mean, only focus on the information available to that date, available to them to that date, right? So the question is, does the large language model follow this instruction or not, right? So what we do what we do is that I'm going to show you that if we give them the ability to recall, they're not going to do well. Okay, I'm going to show you the robustness. And the other thing is that I'm going to show you is that while the large language model does better than humans, it still doesn't catch. It still doesn't catch certain features. So they're also wrong. When humans are wrong, I mean, they're not accurate in terms of capturing the realized values. So if they had this ability to perfectly recall the data, then we should have expected, right?
Yeah.
Them to perfectly track. So I'm going to show you that. But when I do the robustness, if you have some other idea how we could be more convincing for that, please, let us know.
Okay.
Can I just chime in? I'm sorry. I think the question, this is Anna, one of the co-authors. I think the question was about updates to the macroeconomic data, like new revisions. And we do use real-time data. So we do use the vintage that was available to the forecaster at the time of the survey. Okay. So we do a control for that. Just want to make that clear.
Thank you. Thank you for this.
Can I ask something?
Yeah,
also?
this is this section, I guess. You have the most recent real-time data. We have the,
Yeah, Daniela, we have one question of Doron, but just before we have a question from Ariel Karlinski. Okay, it's in the chat.
Yes.
Okay, Doron.
Okay.
Yes.
Yeah, thank you. Okay, Daniela, when
Yes.
you look at the model was built and the parameters were constructed on the corpus of the internet.
Yes.
Which basically means that the calibration of these parameters, whether we want it or not, whether we guide the agent or not, they will already incorporate the data, which is here is future data.
They could.
So, I mean, there are two levels of ignoring future data, relative future, as you say.
Yes.
After date Q. One is telling, and whether you trust or not the agent is one thing, but the agent was born and raised and parameters were calibrated already on the complete data.
Yeah.
Which,
so what I want to say about this is I'm going to show you that, again, we don't know what they look up, right? We don't know. We have this robustness about allowing them to recall. So we'll see what, and also we are in the process of doing a true out of sample, if you like. So we launched some survey in 2024, for example, and we're planning to do some more. And in 2024, the model didn't have basically the most recent data available to the model was until the end of the fourth quarter of 2023.
September 23, that's right.
Yes.
Yeah, I
so
think
in
this
2024, in 2024, we also did some surveys.
Okay.
Because at least we can control for right for the 2024.
It depends on the version.
Yeah.
On,
so and for that, unfortunately, for that, unfortunately, I don't have much to show because we only have very few data points. But we are doing that. But an indication that it doesn't look like that they take full advantage of the information because potentially they could go to the website of the Survey of Professional Forecasters and get right.
Yes
the
and
data
no,
get
because yes and no, because they are not actually requested to correctly forecast. They are requested to be some described human being. Okay. So if you ask what was the data point, they will tell you. And another thing is that there is a parameter, a calibration parameter in this model, which is called temperature.
Yeah, temperature is one here, actually. Yeah.
Okay, so temperature will make the same agent, given the calibration, will make the same agent predict different things.
Yes, yes.
So not perfect recall, not perfect forecast is built in the model.
Yes,
okay,
but
even the same person will.
Yeah.
So he or she cannot be correct twice on two different forecasts.
So we did we did for each persona, I guess, right? while the temperature was 1. We also tried in the robustness with 0 and 2, and in the end, it seemed that 1 seemed to be the best option. But let me tell you why. I mean, I think there is this concern, right? But
yes,
I can show you. I mean, I want to show you that it doesn't perfectly recall, right? I mean, even if there is some recall, it doesn't look like.
Okay, so and one last suggestion about this, the case of ChatGPT-3 was indeed like a point in time, which is an opportunity. So one can think about building now in real time, building this survey, and then wait for a couple of years and see the predictions.
That's what we did in 2024 also.
Okay,
and we're
but
doing
we
we plan to do now. We need because we also need enough data points. Because I'm going to show you that depending on the quarters and the years and so on, right? It's we are doing that. Yeah, we're doing that because that would be a true out of sample in a sense, right? Yeah. So so in terms of data, we were giving the real-time data at that time, right? Or today of that time, and the previous quarter data. Okay, just the median forecast for the previous quarter. And again, we were instructed them not to use any data beyond the current date. And we were asking them to provide numerical values only, okay? And with that format. So results. So we have a very large data set, you can imagine, right? Because we have 25 years from 1999 to the last quarter, the first quarter of 1999 to the last quarter of 2023 for 22 variables at these different horizons, okay, for both human and AI forecasters. So here for the presentation, I'm going to focus on 4 of those variables because these are key macroeconomic indicators. So the CPI inflation rate, the 3-month T-bill rate, real GDP, and employment rates. Importantly, we didn't cherry pick to make the results look good. We could have picked other variables to show, but I'm going to show you also overall. Okay, I'm going to focus on those, but I'm going to show you also some tables for all the variables. So this is what is this reporting. This is reporting the median comparing human versus AI. Median forecast for 1 quarter ahead for the CPI for both human and AI. And human is in gray, right? The gray thick line. AI, the thin black line. And it's 4 quarters ahead. So as you can see, I mean, there are some differences both for CPI and to some extent the T-bill rate, especially for longer horizon. And what I was saying about both, right? So the dotted line is the realized, okay? So what I was saying before is that if the large language model was going perfectly, right, to recall the data of the period, it could have been overlapping with the realized. But otherwise, the gray, the shaded areas are the NBR recession identified quarters. So this for CPI, this for the T-bill, and here actually in this case, you see these are the realized values, and for human for GDP for unemployment rates, they track more closely, right? For the median forecasts are more closely aligned, and similarly for the GDP. Okay, so what about these are the medians? So what about forecasts, right? Distribution of forecasts. Again, here we selected just for illustrative purposes some quarters and some years. Okay. So in terms of years, we picked the earliest available, which was 1999 quarter 1. Quarter 1 of the latest available, also 1999 is a relatively stable period. And then to 2008 and 2020, more of this crisis-like period, global financial crisis and the COVID-19. So what can we see this one actually for the densities of forecast center that the realized values. And what we can see here is that, I mean, there is at least some overlap. We don't know, right? I mean, potentially with large language model, with hallucinations and everything, we could have also had some differences. We have also that for both humans and AI, the forecast densities tend to become more dispersed at longer horizons. So there is, if you like, higher disagreement at longer horizon. And furthermore, maybe not surprisingly, I mean, we'll see that we did some tests. Also, disagreement tends to be smaller for the AI agents. They're more uniform, right, than humans. So this is like, again, just showing you, giving you an idea of the densities. For unemployment rate, as you can see here, they are very different, right? The human forecasters have much more dispersed forecast than AI. Okay, so what are the main messages of this? So median forecast, they're closely aligned for GDP and employment rate, less aligned, some departures for other variables. There is significant, in terms of density forecast, there is a significant overlap for both AI and human, significant overlap. Both AI and human forecasts exhibit higher disagreement at longer horizon. There are the distributional differences, especially a longer horizon. And then we did some tests, and we do find that human forecasters tend overall to exhibit lower disagreement. This is basically stable, shows the percentage of survey quarters where the distribution of AI forecast have lower standard deviation than individual forecast, and using randomization tests. And we can see that for most of the quarters, here I highlighted the variables I'm showing you in the paper, but for most variables, that's the case. But the question is, who is more accurate? And again, we did some tests. So what does this table report, right? So here we measured accuracy as a mean absolute error between the realized, right, the forecast and the realized outcome for the nowcast, the 1 quarter ahead and 4 quarters ahead. And here in red, we highlighted the p-values from the randomization test for comparisons where the AI forecast are more accurate than the human forecast for these 4 variables. So you can see here that most of the time, right, with higher, most of the time we have higher accuracy for AI, and this is showing all the variables. Okay, so I wanted to show that we were not just cherry picking. This for section 1, I think we have section 2, and so on and so forth. But I mean, basically, the overall message shows that in terms of mean absolute error, AI forecasters are doing better. And
hey, Daniela?
here, yes.
We have a question from Akiva.
Yes. You're muted.
Akiva, you're on mute.
Okay. Like, why do you care who's more accurate? I mean, in other words, if the forecasters were generally wrong, why wouldn't you want the simulation to also get it wrong? For example, there's this phenomenon called the hairy chart of interest rate forecasts throughout the decade of, following the acute phase of the financial crisis until the beginning of COVID, where market forecasts, depending on surveys, all the forecasters got interest rate predictions wrong by a lot.
Yeah.
And the question is, would you want the LLMs also to reproduce the hairy chart or not?
No, I don't want that. But what we're saying here is, okay, we took kind of a naive model, if you like, right? So survey of professional forecasters despite their biases, and we know, I mean, there are studies showing that they have biases and so on, still they're used, right? For policy purposes and so on. They're not always reliable. It's a piece of data that policymakers have used. So here what we're saying is, this is in a sense also about the interpretation of our plan. Here we're saying, okay, take a bit of a naive model off the shelf. We only fed, right, the previous quarter, the current data, and so on. They seem to be doing as well as whatever, like, or better. I don't know. I mean, I want to put this huge premium on better because, I mean, they also don't get right some. But what we're saying is that potentially these models could be enriched. You could make them more sophisticated, right? You could give them, if you are even a professional forecaster, you could, and I don't know, you see what I'm saying?
What will they forecast once they see the results of the LLMs? That's another question.
No, but also if you can use the LLM, yeah, right, to your advantage, right? If you are an expert, maybe you understand but also as we learn more about the biases of professional forecasters, maybe we could somehow instruct the model to try to avoid those biases or something. So right now, imagine we took, in a sense, a naive model, right? We only gave a few pieces of information, because even about the past, we only gave the previous quarter, right? So, yeah. So this is about that. So there are some other questions. Should I take them now?
If you want to, can get the answer, because I mean, if you want to predict whether somebody's going to go out and buy a car,
yes,
he's going to go out and buy a car based on his forecast, her forecast, and if it's wrong, then if you want to figure out if he's going to buy the car, and by figuring out what his forecast is going to be, then you want to generate a forecast that's also going to be wrong.
Yes, but I mean, you as policymaker, that's the best you can do right now, right? So the best you can do, I mean, the policymakers right now, they use the survey, they use professional, these are quite sophisticated people, okay? Right. They might have better from the Teal book or something. But I'm saying, we do the best that we can given the imperfections that we have to face, right? So what we're saying is, there are some, and then again, one could try to dig deeper. And indeed, by the way, despite the fact that we get wrong stuff, okay? There was a paper that I mentioned that's unfortunately it's part of our life that we cannot get everything right because there are many unpredictable things. But one paper that I cite here, for example, Heng et al., they find that the SPF outperforms other methods in forecasting inflation. Of course, if we had a magic ball that we could tell what happens in the future, it would be the best, right? But this is in a sense one of the best forecasting tools that we currently have. Can we improve it? Probably, because if we already with this naive large language model, we managed to do as well as, I mean, if not better than these professional forecasters, then we can potentially.
I want to.
So it's not that I want the machine to get it wrong too, right? I mean, I would like potentially to improve.
I don't know. It depends on the question, but I think you do. You do want the machine to get it wrong, if they're getting it wrong, or you may want it.
Yeah, I don't know. I mean, it's.
I'm sorry to interrupt.
Anyway.
We can continue the discussion.
We can continue. I suggest
that
some of these questions I would prefer to defer to the interpretation of the findings, and we're happy to hear.
We have another question by Daniel. Daniel?
Yeah, hi. Yeah, actually, Akiva stole quote unquote my question because I think the title is misleading. If you want to simulate, the title is simulating the forecasters, so why aren't you trying to simulate the forecasters? If you're trying to outperform them, why do you need this whole exercise? Just tell ChatGPT, use all the information. I don't want to simulate anything. Use all information until that point, and then I'm going to show you that I can beat it. Like other papers that I've shown, forecasting. So I feel like right now, I don't understand the motivation of the paper.
No, the motivation was, as I mentioned, ex ante was not clear, right? Who would do better, right? So the motivation was, can we use large language model to to augment the existing data? Because we could have had something that was completely different, right, from what forecasters do. There are these hallucination issues. We don't know what they look at on the internet and so on and so forth, right? So the question ex ante was not clear what was going to happen. And here the question is, can we use it? Actually, we didn't have a stake. Like our aim is not necessarily at this stage to propose a model that beats whatever forecasting models people are using now, right? So we just wanted to understand whether we could replicate some features of the data, and so it could be used to potentially augment current data, given that it's only quarterly, and we only have 40 people in the sample, right? So also for power purposes and so on and so forth. So it turned out that, again, I'm not sure how one could see this message as they outperform, but I would say that they exhibit similar features as like their forecast exhibit similar features to human forecasts, right? So here, percentage of more accurate. So this is again showing an idea of accuracy, but in what sense? Because again, we have that in some quarters, AI outperforms humans. In other quarters, human outperforms AI. We did some analysis to figure out whether there would be a pattern, for example, during crisis periods or not, and so on and so forth. So far, we didn't find much of a pattern. So what we decided to do is to look at the fraction of quarters where AI has lower forecast error. And again, we have some indication that AI do well. Okay, I'm not sure they do better. I mean, our results show that in many cases, 70%, 69%. But the point is not to say right now. Our point is not to say we are showing a model that is even better than SPF, right? Because SPF in other papers have been shown to do quite well. It's just to show you can get comparable results, so you could probably use to augment the data. And we also
Daniela,
focus. Yeah.
We have a question from Naomi.
Yeah. Yes.
So you were a bit agnostic in how you described it. You didn't necessarily say this was good or bad. And so what I was thinking was that in some ways it almost seems like the LLM has a bit more groupthink than the forecasters do. And so that could be okay during regular times, but I'm wondering if during sort of, if you think about the 2008, 2009 financial crisis, that's important to have outliers, which only seem to really be happening with the human forecasters.
Yeah. I think there are sometimes outliers also here, right? Here you see 2000. There are some. I don't think we have a specific pattern in terms of that. We looked at it because, for example, also here in this picture, you see these are centered around the realized values, right? So potentially being close to zero is good, right? Because the forecast error minus the realized value. But you see, sometimes we have that, for example, here, the AI is better. Here being closer to zero, also we find that these are relatively closer, right? But there is no specific, we don't find a specific pattern in terms of that. So, yeah.
Yeah, no, I guess
it depends on the variable and the quarter. Right. So I cannot give you, but it's definitely true, and maybe it's not surprising because LLMs are not as heterogeneous as we are, and maybe they don't have forecasters. They use also their judgment, and actually, especially at longer horizons. And I think in terms of crisis, there is probably more heterogeneity in judgment, right? So. Yeah, so it's not, I don't think that's surprising, but, and again, this was kind of a very simple model, so to speak, right? Yeah.
Thank you.
Yeah. So what we find here is that AI forecasters perform well. We provide them with these personas, real-time data, previous quarter, median forecast. So what happens if we progressively remove these features? what happens if we allow them to recall. And also we did some exercise to, for one of the variables, the CPI, we asked them what affected their forecast, right, to explain in 1 or 2 sentences. We also did different LLMs to make sure also that we have different time periods as well, just to for robustness purposes. A different persona creation, the real auto sample, the one we discussed, which is though still in progress, and hopefully we'll get some results in, I mean, it's gonna take a few years, but to have full results, but I mean, at least some suggestive results soon. So let me tell you what does it mean that we remove the persona, real-time data, and previous quarter median forecast. So for the generic forecast, what we call the generic forecasters, we removed information about their name and so on and so forth, right? Okay, so we had this, the forecast, but all the other parts were the same. For the prompt, where we use the generic forecast without real-time data, we didn't put neither their information, right, personas, and also we removed the access to the real-time data. For the one without real-time data and past SPF data, we remove the personas, right, sequentially, these most recent time data, and also the access to the previous quarter. And finally, for the recall, we just did a very simple one where we just say, suppose you are in this date, for example, quarter 4 on 1999, what's the value of the following variable for that quarter? Okay, which again, potentially the program, I mean, the large language model could look it up. So let's see how they performed. Again, here in this table, we provide the relative accuracy of the forecast with varying level of prompt information. So it's basically the absolute error coming from the mean absolute error coming from the for the generic, let's say, so for the new prompt divided by the baseline, the absolute error for the baseline. Okay, the baseline by the baseline I mean the one with all personas and everything. So basically numbers greater than 1 indicates that the model is less accurate because the number in the numerator is larger, right? So the absolute error is larger than in the denominator. And so as you can see, and this one, I mean, the stars here is denotes significance using, again, randomization tests to evaluate whether values are significantly different than 1. So what we can see is that in general, and this is actually for the nowcast and 4 quarters ahead, by removing the personas, it gets less accurate. The model, right, becomes less accurate, significant for the 4 quarter here. Generic, no real time, also not accurate, but where we get also a lot of difference is where we remove, when we remove the past quarter data. So basically removing past quarter data makes the model, the performance of the model, at least in terms of accuracy, worse. And this is the case of recall, where in one case actually for the T-bill, it does better with the ability to recall compared to our original. And this is for all variables, just to give you an idea. Again, the red is where AI tends to be with lower error, okay, or for forecast error. So data is the key, basically, and not only, I mean, especially the past quarter. So in terms of the reasoning, we analyze. Daniela? Yes.
Just, I would say you have 10 minutes, more or less.
Okay, yes, that's good. Thank you. That's good. Yeah. I actually thought I had the 3, but okay. So yeah, data is very important, right? So what about the reasoning? So again, this one we did just for the CPI, and we use different methods to analyze their answers. And as you can see, I mean, most of the answers seems to be mentioning its monetary policy, consumer demand, or economic recovery. And here is an example of an answer that they give. The LLM gave. The forecasts are based on current macroeconomic data, historical trends, gradual recovery seen in the economy, alongside with stable. So it looks like it looks at different condition. So what is the conclusion? And if you like, also we can discuss. I'm happy to hear your thoughts about interpretations and of these results. So here, what we think is that we took a model that is relatively simple, right? We just provided some pieces of information, not even the whole history of median forecasts and so on, but we show that this can provide more accurate forecasts than human forecasts for a wide range of variables and quarters. Maybe, I mean, I shouldn't stress too much the more accurate, but I mean, I would say similar forecasts to humans, in some cases more accurate. So how do we interpret these findings? These findings, together with existing studies, for example, the Faria Castro and Ludovici, right? Lubovic, they did it for the CPI inflation, for the CPI, for inflation. We think that our studies, together with other studies, have showed that the LLMs have the potential to enhance current data collection, survey data collection methods. So it could help to improve, if you like, the sample, right? The forecasting sample, in terms of increasing the sample size and decreasing noise and so on and so forth. So we also think, as I mentioned, this is a very simple model, that this could be potentially the professional forecaster. They already use their models, right? And their judgment. They potentially can take advantage of this type of model, LLMs, to extract, to extrapolate patterns of the data that they might be interested in, or particular points in history when certain things happen, and so on and so forth. So they could potentially use it to increase forecast precision by integrating it with their models, judgment. And also we have papers that show that also professional forecasters, despite being sophisticated, right? Sophisticated agents, they still suffer from some biases. Maybe there is a potential also to correct for those. And ideally in the future, there could be a potential for human in the loop, where they could, as professional forecasters, maybe as policymakers, as a matter of fact, one could have their own large language model trained on specific data that policymakers care about, so more tailored model, okay, like that is trained on specific and relevant domains, okay. So we are in the process also of testing if this framework could be used as a laboratory to explore, pretest, and refine the hypotheses, for example, regarding the impact of the Federal Open Market Committee's communication strategies or other treatments on forecast performance. And this is especially valuable for these samples, specialized samples like the survey of professional forecasters that are hard to reach, and also it's kind of difficult, right, to potentially conduct some experiments with, right? And also here we focus on the point forecast, but we think that this framework could be also extended to study uncertainty in addition to point forecast in future work. So as I mentioned, the survey of professional forecasters also is a distributional, a density question. So a least probability distribution on certain bins for inflation rates, right? And maybe in other variables, for other variables too. So our framework could also be extended to study uncertainty in addition to point forecasts. So thank you. I'm done. So I'm now open for questions, criticism, and
thank
so
you.
Yeah.
Thank you, Daniela. I'm taking Jonathan's place here. Thanks for a fascinating presentation, and thank Sophia for answering question on the chat. Was very efficient.
Thanks. Yeah.
Yeah, so I guess we'll open the floor for questions, 15 minutes more or less, and then general discussion after that, whoever wants to stay. We have one question from Luigi. I'll start with a question and then we'll go to Luigi. My question relates to what Naomi said. I think that the issue of dispersion is understudied. I think the most striking figure I've seen is the second quarter of 2020. You see,
I agree.
That's the height of the COVID crisis. You see, no one really knows what will happen to unemployment, but LLMs are quite sure it will be 5. And
do I have the realize? Let's see. Do we have realize for the CPI? Yeah, we have something here, at least in terms of median, but not the 2020. So what was for the unemployment rate? It was unemployment rate, right? Sorry.
Yes.
Unemployment rate.
Forecasters were all over the place, and the LLMs were quite sure it would be 5.
5. So yeah.
This kind of maybe underscores the issue of real-time data, and if you can really tell the model to ignore something. The other thing,
yeah, I think the best for that is the true out of sample that we're doing now.
Yeah.
But so to fully address, address that, yeah.
And the second issue is that you sometimes see a bimodal distribution, kind of the group thing that Naomi said. I think it's interesting to see when that happens. Why? I mean, because you might think of, forecasters trying to predict the mode outcome, whereas the LLMs try to predict the mean. And the disagreement in that respect might be interesting why that happens. I think I would dig deeper into those events and try to think about why the LLM says what it says. So that's it on my behalf. Luigi, you're next.
Thanks. No, really interesting presentation. I have just a couple of comments. One, okay, when do you think you will be able to publish some results from your real out of sample exercise? Because I see you have a website up and running, but when you will feel confident to also publish some analysis about your result of this? Because one of the drawbacks of working on such a long time series is that even small difference becomes significant if you have enough points. So in a lot of cases you were presented your result in which there is a significant difference, even if the margin is really narrow. And in the case, the fact that you have a lot of observation is obviously skewing the significativity of your result. And another comment is whether you looked also in another class of large model, so a large time series model, because I mean, one of the concerns that I do have into using LLM for such an exercise is that indeed those are models that are trained to predict the next word really well, or the next token really well. So predicting time series is not really what they were meant for, rather than those large time series model, which are instead trained on a large, on a huge data set of time series, which are exactly the exercise you're pointing for. So those are my two comments on this.
Yeah, side. I mean, we didn't compare. Here, we're not comparing with time series, right?
Well, I mean, in the end, your forecast is so those large time series model, they take whatever information you want. So your own series, other covariates in the future, in the past, and I mean, there is a huge variety of model, and then they help you to predict points in the future. It's just for numerical variables. So rather than a large language model, which is let me say, much more generalist, because large language models is trained on
yes,
on
it's not special. That's why I was saying there is a lot of potential for human in the loop or for humans, right? Like we're not at the stage yet where the forecaster or the policymaker can be in charge of training the model, right? We're not there. But I think at some point we're going to be opened up those large language models, right? Either through open source or something. Companies might be able to use them to train them more, to provide more tailored training. For example, as you were saying, using models that you think are more relevant, or data sets that are more relevant, and so on and so forth, right?
Yeah.
So this could happen, right? Today. So what we're saying here is we took a naive model. Okay, we did with the recall. The best we could do now is also to allow them to and show that they don't do better if we allow them specifically, right, to recall. We did the reasoning just also again to try to understand, but I mean, in the end, we use also for professional forecasters, right? We're using their forecasts. And we also don't know exactly what they do, right? We know that they use quantitative models and they use their judgment, but we don't know exactly what they're doing, right? So here we find that large language models, despite not being specifically trained, right, for that specific domain, overall, and again, our point is also that we wouldn't discard, let's say, the data from professional forecasters. Our idea would be it could be just a way to augment, right, this data at this stage. But I mean, the auto sample, we would like to publish this paper hopefully earlier than 3 years, even because I mean there is a lot of work, right, being done, and we find that across models we still find robustness, right, even though these models are potentially. So I'm not sure, like, what would convince you that. So are you skeptical that this cannot be used as a way to augment existing forecasting data, or what is?
My point is, okay. I mean, I'm skeptical on the let's say on the past, because anyway, those models were fed both the real data and the professional forecaster past exercise. So it's all public data on the internet, so it's all part of their training.
Yes.
So I'm skeptical on the on testing on the back, let's say, on something that I mean inherently cannot be taken out. Yes, because in the end, what they do is that they, given your prompt, they will give you back what are the most probable, let's say, tokens afterward.
Okay.
So and this will include the fact that you put them as some place in the past, but this doesn't mean that they forgot their training data. They just mean that they are calculating their probability, in a certain way for the output they give to you. So instead, if you have more points on something that they really never saw, that will be more convincing to me. I'm going to say I'm more fair proof of their ability to actually, let's say, add value to the forecast.
Yeah, so I don't think I put here the out of sample. So in the paper we do have the results. I mean, of course, there are a few data points, right?
Which to me is even better, because as I said, if you have too many data points, even too small difference becomes significant.
No, but I mean, we do it. Yeah, we do it for all the. So what I can say is that we can do more work, right? For that, we have it in the paper. By the way, it's the table 10. I should have put maybe here. I didn't put it because I was not. Maybe I have it somewhere. But so basically, yes, for now, because we have only few for 2024, basically we had it because the model is up to 2023. So we had, sometimes AI is better, sometimes. So the results are not in terms of also randomization tests. we don't find significance, right? Because the sample probably is
it's too small to
it's too small. It's too small. In terms of at least for who does better and so on, we find that it depends. We could calculate maybe at least to have an idea of the fraction, of some fraction. Yeah, another thing that yes, so basically I see that in some cases is it tends to be AI. I have to check how more often, who is more accurate, right? But I mean, the results are not that significant, but we get, right? We tend to get for many variables. Yeah, so we need a bit more data, but the best we could do right now is to allow the model to recall versus not recalling, but in any case, I think it's still. I mean, it's still good news. Like the large language models can replicate. It means they look the information in the right. Even if they look at
interesting was to me, I was also looking to large language model for replication. Let's say to replicate interactions. So
yes.
That will be that will be also interesting. Even though, I mean, if you do use it for the past, you run into the same risk that the models inherently has been trained on the past. But if you can do enough auto sample, then it will it will give you the chance to check how these models can replicate.
But I'm also doing some work. Ali is also involved in that for interactions for an experiment. Actually, it's not related to this. And exactly with that purpose. Also, experiment in a sense is easier because they didn't see the large language model. Most probably didn't see that particular experiment I'm doing. You know, this is an interaction of subjects in the lab. They interact in groups, and it's a new experiment. So they haven't seen that type of situation before, but that's some work in progress, and that also will help to better understand how important, right? If they can mimic what you need, what kind of information. Like if I give them even there you could use it for auto-sample predictions, right? You can give data about the current experiments, ask the model to make predictions about what players would do, and then run more experiments, right? So
since you have as a model, you can run thousands of simulation and then get a
exactly
kind of probability.
Exactly, and you yes, it's true. So, but here we can provide whatever we have up to now in terms. I think what's the recall, I guess, was the best thing we could do. We could also ask, but I'm not sure what the model answers. But overall, I think it's highlighting still the potential for these tools to help either augment the data of professional forecasters, right, the current data, or for future, if at some point we're going to have more flexible large language models that could be trained under certain conditions, it would be dangerous, I guess, to allow any company to train models and stuff. But I mean, if we could have that options, they could be even more sophisticated, and you could correct again for biases.
I'm going to put just in the chat a link to one of these large time series models. In this case, it's one by IBM. But those are models which are being trained on a massive amount of time series at different frequencies, which those can be used for forecasting. And the architecture is somehow similar to large language models. Most of them are based on transformers anyway.
Okay, that's good because we could compare also.
Yeah, even though I mean, any time series in the past probably has been so by those models. So for the past, I really.
So your point is probably that maybe these they have access even to these models, and maybe they even take something from.
Those models are now open on the internet, but if you use the API from OpenAI, probably they don't use directly those ones that I put in the link.
Yes, exactly. Yeah.
But this type of model start to exist. And I mean, for a forecasting exercise, I mean, a real forecasting exercise, not back testing, I would say that those models also deserve a shot because they are trying exactly to do this.
Yes,
predict,
to predict it's a similar structure, but it's more controlled.
It's only numerical values, only time series.
Okay, sounds good. Yes.
Okay,
so these are new models. These are new models.
Yeah, this is a new family of models. Now I just took one, but there are like 10, 20 different options that are now available.
Okay, thank you. Yeah.
Okay, thank you very much, Luigi, for your question. Do we have any additional questions? Okay, I have one from my side of policymaker. How can we use your results concretely as a central bank?
So what I think you could use for, again, with humans, there should be human oversight and everything. But I mean, suppose you would like to have maybe more data points to better understand if certain trends are robust, or you can use to augment, or maybe the frequency if you would like to have more frequent data. That's how at this stage I would use, but also maybe it could be used. I mean, these large language models are advancing very fast, right? Maybe there could be, I'm not sure, you're not yet at the stage, but we're not yet at the stage, right, of having I mean, being able to train your large language model, but it could be potentially an additional model, right, to use in addition to other models that you use to make your forecast. I think you probably already use to some extent professional forecasters. I'm not sure exactly to what extent you use some quantitative models versus you probably integrate many sources, right, when you make your forecasts.
Yeah,
large language models. Yeah. Yes, you were saying?
No, yeah, I'm telling, yeah, we're using all this model, but if I understand your reply,
so you can use an additional source.
Yeah, but it's not only for interpolation, correct?
Jonathan, maybe I can chip in. Basically, you could provide an environment that will tell us the feeling in the street of various clienteles, even various clienteles. So it is an as if what was felt by the market, by the street, by people of different demographics at a specific point in time. And in order to pursue this kind of, or this line of research, I think you can try to validate within your data the role of the personas.
Yes.
One way of doing it is to first do a pairwise comparison of the results of the forecasts. Okay, so we have the real John Doe and the virtual John Doe. So a pairwise will provide different results than the sample t-test. Okay, yes. And then going in this direction, you can also try to see whether an LLM can identify, reverse engineer the persona that has given the profile of forecasts.
Yes.
So that will close the loop.
I agree a lot. So the problem we have right now is that for the survey of professional forecasters, we don't know. We cannot link the name.
Yes.
To the, but there is also Jonathan is a paper, right? We uses a different data set. And it was linking, but we have also, we have some data from from a survey from the Wall Street Journal where we can also do a bit more of that.
And in experiments also.
In experiments, exactly. The experiments would be very useful to see how different types might react differently depending also on sophistication level, right? To information and so on. But also it's very interesting, the idea of reverse engineering. This is also for insurance. That's what people are worried about, no? Right now.
And you could do it also within the current data. You can try to see whether the LLM can reverse engineer the specific persona in a, to see whether to what extent it contributed to the forecast, to the profile of the forecast.
Yeah, we need to, but it could be, I mean, at some point definitely could be possible, right? Right now,
already in the current data, you can do
the current data. We need to do more. We need to do a more in-depth analysis, right, about this, because again, we have many quarters and many characteristics, and we need to check more specific patterns, maybe compared to what Jonathan found in his sample. But I definitely agree. There is a lot. There could be a lot of potential, right? For that,
Okay, thank you very much. I just have one technical question, and then I will stop, except if we have any other question from the audience. I don't know, maybe you replied to this question before, but I just want to be sure on how you treated this issue. Is okay, so it's a big black box. Well, we have this big black box that is called AI, whatever, GPT and whatever, but it contains all the information, all the forecasts, so all the realizations, the effective realizations.
Yes.
So how do you treat this issue? How do you remove the fact that this black box knows already the truth to compute him to be a real forecaster, not knowing the future?
Yes, that's the question was discussed a lot, right? Is this that at least up to 2023, right? It's not real out of sample.
No, I saw this, but my question is how are you sure that the big black box will not overcome this request, because you are making a lot of several requests?
No, the only thing we can say indeed is when we remove data, let's say we don't give real-time data, right? It does worse, even though potentially could look up the real-time data, right?
Yeah.
So we are giving, if the information we were giving was kind of redundant, or we were, right? So they could look up when we give in the prompt, right, where we don't give, what is it here, right? We remove persona. Okay, without persona already, they tend to do a bit worse. So it means personas at least are doing something. So when we remove here, you see, we don't tell him you have the most recent real-time data. Even though the large language model could look up, right? Could look up that information, they do worse. And when we also don't give them the median forecast, even though the large language model could go and look up, right? We tell them you're a professional forecaster. Potentially they could go. And we tell them, give us your best forecast, right? So even if they could, they do worse. So it means that by themselves, without a prompt, they don't go, right? They do worse, you see? So this stuff, when it's higher than 1, means that the baseline model does better with real-time data. And so it means that unless we give some information, it doesn't necessarily go and look up, right?
No, but Daniela, you have to reconsider it with respect to the question or the task that you have given the LLM to do, because the LLM was not requested to correctly predict the future.
No, we said
it was requested to imitate a persona.
Yes, but we said your best numeric forecast, right?
Yes, but you are this and this. What will be this and this person best numeric forecast?
Okay, that's true.
It's a little different. I think it's more.
That's true. Indeed, my student, Ali, is where it does the survey of consumer expectations, and it doesn't say that they're professional forecasters. Indeed, they do worse than professional forecasters. So, but what I'm saying, even if we tell them you are a professional forecaster, when we don't give the data, it's not that then necessarily the large language model goes and retrieves, even though that information is there, right?
The fact that a single, actually, it's a single number almost, makes a difference, make you think how and to what extent they use all the other data. But I think that's why it's even more interesting, the idea of comparing personas to virtual personas, because people tend to select or to filter data according to, human inclinations. And they also, I think, every forecast, at least, of course, for professionals, will start from the last number and then try to correct from there. So whether this number, exactly. So whether this number or some variant of it is highlighted or not makes a huge difference. And that's actually of concern to banks also, I think, Jonathan, because related somehow to our work, we would like to think, how will this population behave given some announcements, etc., or some policies? So
that's our plan. That's our plan here for this second to last bullet point, because the communication strategy of the Federal Open Market Committee has changed over time, right? 2012, they introduced the inflation targeting value, right? So the plan is also to validate the model potentially, right, using that, because we can do that and compare with the real data and see if they became more anchored, uncertainty decreased, stuff like that, right? So that would be further validate.
Jonathan will know what I mean. I mean, people tend to be myopic. We have work about this, and to what extent the reaction to different announcements and policies, I think it's a great deal, because the whole dynamics hinges on this. But there is the ground, truth about models, and there is intervention of people behavior. So, and these are two different interesting questions. How people will react, whether they will over or underreact, to what extent, and how Horizon makes it different. That's very, very interesting and important, I think.
Okay, thank you very much. If we have any additional questions from the floor, please raise your hand. If not, thank you very much, Daniela, for this fantastic first paper, presentation, slides, and excellent discussion. I have to be honest, it was very interesting and a lot of participants to this discussion. So thank you very much, Daniela.
Thank you so much for the feedback. We really appreciate it.
Thank you. Very nice. Very nice work. I enjoyed it a lot.
Thank you so much. Thank you.
Thank you. Have a nice day. Thank you.
Bye.
Bye-bye.